Hello, my name is Faith Gray.
And I'm Lauren Lockhart, and we are doing the Physical Properties and Concentrations Lab.
A meniscus is the curved portion of water or a liquid that forms when it is measured. Because of surface tension, the water molecules crawl up the side of the pipette and creates a concave lens or curve. To read the volume of a liquid with a meniscus, you read from the bottom of the meniscus into 1 degree of uncertainty. For challenge 1, the 125 milliliter flask must first be placed on the balance, so we can use this mass to determine the mass of the water placed in it. The mass of the balance is 82.81 grams, which does not need to be measured to a degree of uncertainty because the mass gives an exact measurement. We then perform 2 trials, collecting the mass of 3 different volumes of water in each, which can be seen in the data tables labeled number 1. This particular volume was 9.83 milliliters. Then, we transferred the water to the 125 milliliter flask and weighed the water in the flask, which was 92.13 grams. This data shows the process of determining the concentration of the diluted solution and the density of the stock solution. The diluted concentration was found with the C1V1 equals C2V2 formula, and the average density of the stock solution was found to be 1.36 grams per milliliter. For challenge 2, the 25 milliliter volumetric flask is used to hold and dilute the 20% sugar stock solution, so the mass is found for later use, which is 19.488 grams. We then measured 3 different volumes of the 20% sugar stock solution and transferred it to the 25 milliliter volumetric flask. This volume of stock solution was 3.71 milliliters. The mass of the volumetric flask and the stock solution is then measured, which was 24.268 grams for this particular trial. The stock solution is then diluted or filled to the 25 milliliter mark with water, lessening the concentration of the stock solution. The difference between the stock solution and a diluted solution is that a stock solution is a concentrated solution, which is then usually diluted with water to lessen the concentration, creating a diluted solution. This data shows the process of determining the concentration of the diluted solution and the density of the stock solution. The diluted concentration was found with the C1V1 equals C2V2 formula, and the average density of the stock solution was found to be 1.36 grams per milliliter. For challenge 3, we measured the volume of the known 20% sugar stock solution. This was then transferred to the 25 milliliter volumetric flask, and the difference to 25 milliliters was diluted with the unknown stock solution. This allowed us to subtract the volume of 20% sugar stock solution from the 25 milliliter to 1 degree of uncertainty volume, giving us the volume of the unknown stock solution used. This data was collected to determine the concentration of the unknown stock solution by using C1V1 equals C2V2, where C1 is the concentration of the known sugar stock solution, V1 is the volume of the known stock solution, V2 is the volume of the unknown stock solution, and C2 is the concentration of the unknown stock solution. The average concentration of the unknown stock solution was found to be 10.76%.